All right, this is a very quick um, question review and points, especially for those persons that are writing the 2025 UTME examination. It might just be a night before your exam, or maybe you might be watching the video like 5 minutes to the exam, or anytime you're watching it. I just want to bring out some few questions that JAM do set in the examination from time to time, and use the opportunity to bring out some points from this question. So let's go straight to the issue. Now, the question here, number one question here says the gas formed when ammonium trisulfate 5 is heated with sodium hydroxide is dash. Now, first off, we must be able to analyze and check out each terms and each option. So after I give you the answer, I want you to just know the meaning or some properties of these options. First of all, let's go straight to the answer. For us to know that, we have to bring out the equation for the reaction that they are talking about. Now, the formula for ammonium trisulfate is NH4NO3. Now, they say if you react with sodium hydroxide, which is also regarded as caustic soda, that is sodium hydroxide, they are asking us what is the gas that will be evolved. First off, the sodium obviously will react with the trisulfate, so will now form NaNO3, which is a salt. Now, this salt, listen to the point, this salt decomposes on heating. First of all trisulfate 5 salts decompose on heating. Like all trisulfate 5 salts, they do decompose on heating. And again, all trisulfate 5 salts are soluble in water. That is one point that you must take note of. They are all soluble in water. So what am I trying to say? That this salt that is formed is soluble in water. Now, plus it will now give me H2O plus ammonia gas is giving off. Now, the gas that is giving off here is what? Is ammonia. So obviously our answer is what? Is D. But I will not leave you like that. We have to be very careful. Now, when you're preparing for an examination like this, you don't just look at questions. You try as much as you can to analyze each option that have been given to you. Now, obviously, we have known our answer already. Ammonia gas is giving off. Now, remember that ammonia, let's start from this. The ammonia is less dense than air. So after producing the ammonia gas, the ammonia is collected by upward delivery. Remember, gases that are less dense than air are collected by upward delivery. So ammonia is less dense than air and is collected by upward delivery. Now, remember again that in the preparation of ammonia, ammonia is dried through the use of quicklime. So what is the drying agent for ammonia? Is what is quicklime. Now, don't mind my spanner. Now, quicklime, that is calcium oxide, is used to dry what? Ammonia. Now, that is one point by the wayside. Now, let's quickly come to each of the options and start to analyze each of the options and see the kind of points that we might be able to get from it. Now, let's go to this guy. This is hydrogen. Hydrogen is the lightest gas. Yes, of course, hydrogen exists or has three isotopes, which are the protium, we have the deuterium, and of course we have the tritium. Now, hydrogen again is manufactured in a laboratory through a process known as the Bosch process. Now, I'm trying to analyze each options for us so that we're able to have a glimpse of each of the options, points on them. Now, this hydrogen here is manufactured from the Bosch process. Now, again, hydrogen do not have a neutron number, does not have a neutron number. So if you want to represent hydrogen and represent hydrogen like this, does not have a neutron number except its isotopic forms. Now, let's come back to nitrogen. Nitrogen is the most abundant gas, of course, in the atmosphere. Nitrogen controls combustion. And again, there's one thing I want to bring out here. Now, this is ammonium triosonitrate reacting with a base, caustic soda, to liberate ammonia. Now, there's one question that they usually asks under nitrogen. Please be very wise on this. Now, that nitrogen can be prepared in the laboratory from the decomposition of ammonium diosonitrate. But please, the ammonium diosonitrate must be freshly prepared. Now, if I heat this compound freshly prepared, it's going to give me nitrogen gas plus what? Plus H2O, which is what? Which is water. Now, be very careful that this ammonium diosonitrate must be freshly prepared from what? From the reaction between ammonium chloride and sodium diosonitrate. Now, this is this question. Now, of course, you can see that we have been able to analyze hydrogen gas, nitrogen gas. Of course, oxygen is the most abundant element in the earth's crust and is also found in the atmosphere. Of course, it encourages what? Combustion. Now, let's look at question number 2. We have a lot of questions to throw light on into this episode. Now, let's look at question number 2. Which of the following oxide of nitrogen is unstable on nitrogen again? First off, nitrogen forms 3 oxide. Nitrogen 1 oxide, which is laughing gas. Now, this is the laughing gas, nitrogen 1 oxide, and is used as an anesthesia. It is used as anesthesia. Now, in surgical operations, it acts like a form of a painkiller, so to say. Now, this nitrogen 1 oxide is formed from, remember, go back to this equation now. If I decided to decompose ammonium triosonitrate, not reacting with a base now, if I heat it freshly prepared again, it's going to give me a nitrogen 1 oxide plus what? Plus H2O. Now, you can see the difference now of what we are seeing here. So if I heat ammonium diosonitrate, it's going to produce nitrogen gas. If I heat ammonium triosonitrate, it's going to form laughing gas, and laughing gas is used as an anesthesia. Now, in organic chemistry, under the aspect of alkanes, talking about the methane, some strong reaction of methane, there's a compound that is formed that is also used as an anesthesia in case you come across it in the exam, and that compound is chloroform, which is CHCl3. That is also known as what? Trichloromethane is also used as what? As anesthesia. Now look at this one. This is the reddish brown gas, nitrogen 4 oxide, and this nitrogen 4 oxide, you should also remember that this nitrogen 4 oxide is an example of a mixed acid anhydride. What do I mean by that? That is to say, normally an acid anhydride are oxides of non-metals that react with water to form acid. That's why they call them acid anhydride. Now, acid anhydride are oxides of non-metals. For example, we are having that of XO2, we have that of SO3, we have that of CO2. They are acid anhydride. They react with water to form acid. Unlike this very one here, if you react with water, it's going to form 2 acid. That's why they call it mixed acid anhydride. Now, this NO is an unstable oxide of nitrogen. That's what they're asking us. That is to say, in the production of NO, when the NO is exposed to oxygen, it automatically forms NO2, so it's unstable. This also is nitrogen 4 oxide. This is nitrogen 4 oxide. This is nitrogen 4 oxide. Now, this nitrogen 4 oxide is formed in a quite low temperature, so to say, or mild temperature. Now, this nitrogen 4 oxide is yellow, but this nitrogen 4 oxide is a brown what? Is a brown gas, so to say. Now, so you can see now that we have been able to bring out some few explanation on some certain things. Now, there are other questions I want to review with you, but this other question, now let's check out some more questions on this aspect of chemistry. All right, now look at this other question. Again, a typical JAM question. Now remember, do well to subscribe to the channel, of course, so you can get videos like this in subsequent examination, not just in UTME, but this is specifically for those persons that are writing the UTME examination. So very quickly, let's do justice. Now remember, in looking at all these questions, we're not looking at the answer to the questions, we are trying to analyze the options and looking at each terminologies used in the questions. Now look at this question. Which of the following gases would blacken the wall of a laboratory film cupboard coated with lead paint? Now the answer is what? Now lead is Pb. Now when lead reacts with what? With hydrogen sulfide, look at what's going to happen. Now it will now form lead sulfide. Now this sulfide is what? Is black. So is this gas that turns the wall that is painted with a lead paint to be black because of the formation of lead sulfide. So that lead sulfide is black. So when hydrogen sulfide now react with lead to form the lead sulfide, that's what makes the wall to become what? Black. So they are saying which of the following will blacken the wall. So if if lead react with hydrogen sulfide, of course removing the hydrogen, you form lead sulfide. Remember again, I said lead sulfide is what? Is black. So they can also change it. Which of the following forms a black precipitate when it reacts with lead? That is another way in which they ask such questions most of the time. Now, but let's go back to our options. Now, look at this chlorine. Of course, you should know that chlorine is a greenish yellow gas. Yeah, chlorine is a greenish share log as very important. That chlorine is used as a germicide, obviously. Excess chlorine is poisonous. Chlorine is heavier than air. That is why chlorine is correlated by downward delivery. Remember the question that we looked at just now in question number 2, we said that ammonia is less dense than air, therefore it is collected by what? Upward delivery. But because chlorine is denser than air, it is collected by downward delivery. Now chlorine is a good oxidizing agent, just like sulfur oxide, but the difference is that sulfur oxide bleaches by reduction, while chlorine bleaches by oxidation. But the bleaching action of chlorine is permanent, but that of sulfur oxide is what? Is temporary. So the bleaching action of chlorine is permanent, while that of sulfur oxide is temporary. That is why chlorine is used to manufacture bleaching powder. How is it formed? When chlorine reacts with slaked lime, look at it now, slaked lime, it will now form bleaching powder, which is CaOCl2.H2O. Now this is bleaching what? This is bleaching powder, so to say. Now remember what I said. Why is chlorine used to manufacture bleaching powder? Because the bleaching action of chlorine is what? Is permanent. So chlorine bleaches permanently. Now look at bromine. First off, bromine does not exist as a gas at room temperature. It exists as a what? Liquid, a brown liquid at room temperature. Now you must know something about this bromine again. That bromine, it can be used as anti-knocking agent. I'm just trying to analyze each of the options after getting our answer. So this is just a short video for those persons that are preparing for what? For the UTME examination. Of course, it's coming a day to the exam, or maybe you're watching it maybe few hours to your examination. But just put this at the back of your mind that when you are preparing for an exam like this, or when you have done all your preparations, you must always do well to have a sound mind in looking at the questions. So you don't have to rush the question, you have to understand what they are talking about. So but these questions we have been reviewing are under the aspect of the non-metals. Now there are questions that are coming from organic chemistry that we'll be looking at in this particular video, so you have to stay tuned. Of course, you have to share with your friends, very very important. Of course, tell your friends, of course, to subscribe to the channel. Now let's look at another questions, or let's look at other questions. We have a lot of questions to drop back to back. Thank you. All right, now look at this other question. And if you notice very well, this question is actually coming from the aspect of organic chemistry nomenclature, how to name organic compounds. Now in naming organic compounds, we want to use this as an example, but we're bringing out some basic rules that you should put at the back of your mind. So first off, let's look at the compound on its own. Now let's check out the compound. They said give the IUPAC name of the compound. Now this compound, first off, is an alkyne. I can decide to name this compound straight like this, but for easy understanding, you you might want to write it structurally, bring out the structures out, like represent it structurally first. Now I can redraw this compound to be CH3. We have CH, then we have Cl, then we have triple bond here, then we have C, then we're having what? A CH. Now this CH3 bracket 2 that is here simply means that this particular carbon is carrying 2 methyl. So one CH3, then we have another one CH3. I might decide to put the hydrogen here or put the methyl here, I'll still arrive at the same answer. So regardless, now if we do it like this, it will be easier for us to now name the compound properly. Now this compound, obviously because of the triple bond, this compound is an alkyne. So alkyne have triple bond. Now and let me just chip this in. This particular alkyne is a median alkyne. Why is it a median alkyne? Because the triple bond is not found in the extreme carbons. Now had it been the triple bond was here, which is not possible because of the structure, the triple bond is at the first carbon, is a terminal alkyne, but because it's not at the first carbon, maybe it's here or maybe it's here, now we say it's terminal alkynes. And remember, let me just drop this for you very quickly, that ammoniacal solution of silver nitrate and copper 1 chloride is used to test for terminal alkynes. Now these two compounds in ammonia, so to say, these two compounds in ammonia is used to differentiate alkenes from alkynes. But pay attention, used to differentiate alkenes from alkynes. But please, that these compounds only react with terminal alkynes, which I've explained for us just now. So let's go back to the issue at hand now. If we have analyzed this already, now what do? We have to look for the longest possible straight chain. Now let's check it out. Now 1 2 3 4, cannot be. 1 2 3 4 5. Okay, 1 2 3 4 5. So anyway, that means our longest chain has been established. We have not started the numbering yet, but the longest chain has been established, that is 5. And remember that 5 is pent in the form of pentagon, so 5. But I cannot say pentane because this compound is not an alkane. This compound is an alkyne. So what will I do in this situation? I would therefore say that I have to number the carbon now. 1 2 3, I get to a triple bond. 1 2, I get to a triple bond. So what I'm going to do is that I need to count my carbon from where it's closer to the triple bond. If there's no triple bond here, or where it's closer to the functional group. Now let's go like this. Now it becomes what? 1 2, I've gotten to the triple bond. But if I take it from this angle, 1 2 3, I get to triple bond. So I'm looking for the place that is closest to the triple bond. So it becomes 1 2 3 4 5. I might decide to take it down, doesn't really matter. Now let's go now. So it becomes 2, between 2 and 3, I have my triple bond. So I'll say pent 2 ine. Now whatever is not part of the longest chain acts as a substituent. Now if you notice very well, you notice that there's a substituent here. Sorry, this is chlorine, rather is chlorine. Remember the chlorine there. There's a substituent here. This is chlorine, and this is a substituent. But mind you, this is not a substituent because it's part of the longest chain. Now I might decide to take it down like this. I will still take this as a substituent. But in this situation, this one is not a substituent. So it becomes what? Chlorine methyl. So the substituent should be arranged alphabetically. So I will go like this. So chlorine comes first. So it becomes what? It becomes what? 2-chloro. Get it now? Then we have what? 4-methyl pent 2-ine. So this is the name of this particular compound. Now remember, in giving out the names, I'm taking my time to make sure that I just bring out some hidden things that you must know about this an aspect of chemistry. But this is nomenclature, but I'm using this series of lecture to just review some few things in detail. Now remember that we have alkanes, and we have alkenes, and we have what? Alkynes. That these have single bond, this one have double bond, and this ones have what? Triple bond. Now in the single bond, we have sigma bond. It's what called sigma bond. In alkynes have double bond, but one of them is a sigma, one of them is a pi, but this one is 2 pi 1 sigma. Now remember a very quick one that I can actually convert alkanes to alkynes by dehydrogenation, complete dehydrogenation. But I can also convert alkynes to alkanes by hydrogenation. Now we have a lot of questions to review in this video. Now let me bring out another organic chemistry question that I want us to check out together. All right, now if you look at this other question, this should be question number 5 for today's review for those that are writing the UTME examination. Now remember the idea about all these questions. We are trying to not just bring out the answers, we are trying to make sure that we analyze each of the options and see how we can get some few points before you rush into the examination. So it's a very quick one, very fast. Now let's go. Which of the following is formed when sodium hexanoate? See, you have to underline that. When sodium hexanoate reacts with what? Soda lime. Good. Now before we take our answer, before we begin to check out the answer, I want to know why the answer is that like that. Now look at this, for instance. Now look at the solution. Now if I go like this, I will have what? The formula for normally, this RCOONA, this is sodium alkanoate. Now, when sodium alkanoate reacts with soda lime, now soda lime also have the same formula as caustic soda, which is sodium hydroxide, but the sodium hydroxide has been mixed or slaked with quick lime, but it has the same formula as sodium hydroxide. Now remember, remember, put this at the back of your mind, that we are not using the caustic soda, because caustic soda will react with glass and resulting to etching of glass. So we have to react the caustic soda with quick lime, so now get soda lime. Remember, soda lime and caustic soda have the same chemical formula but different chemical reactivity. Now I will now have NaOH. Now look at what's going to happen here. Look at what's going to happen here. If these react together, sodium, I will now have Na2, then I have COO plus this other oxygen, that is CO3, plus arrow, we are having arrow what remaining H here. Now this arrow H, remember, this is an alkyl. This is alkyl, obviously. Now alkyl is formed when one hydrogen is removed from an alkane, so it's like I'm adding the alkane back to the alkyl. So this is now what? This is now an alkane. Good. Now if you notice something, that this guy has been reduced by a carbon, that means when sodium alkanoate react with soda lime, the alkane formed is one carbon lesser than the alkanoate. So let's go to our question. They say sodium hexanoate, that means it has 6 carbons. Now it becomes sodium hexanoate, so I can write it like this: CH3 CH2 CH2 CH2. This is 1 2 3 4 CH2, 5 CH2, then sorry, COONA. Now 1 2 3 4 5 6. Now this is sodium hexanoate plus NaOH. Now what will happen? Remember what we are saying here, that the alkane formed will be one carbon atom lesser than the what? Than the alkanoate. So what am I going to have here? It will now be 1 2 3 4 5. That means I'm going to have C5H12 plus Nat2CO3. So they can give you any alkanoate at all. So if they say for instance, they say sodium ethanoate react with soda lime. So if it's sodium ethanoate reacting with soda lime, that means it will form a what? A methane. If it's sodium butanoate, it will form what? It will form propane, just like that. If it's sodium decanoate, it will form nonane. So in this situation, what you must put at the back of your mind is that the alkane formed is one carbon atom lesser than the what? Than the alkanoate. So remember what is involved in this particular reaction. So there are many questions that we are reviewing this period. So please, as you watch, do well to share. As you watch, do well to share. Now this is another important question here. Then this one is also from the aspect of the non-metals. Now they said, which of the following element does not exhibit allotropy? Straightforward, no time to jump around. Now look at what we're going to do. We're going to use the back and enter. Now we want to use the option E. We want to analyze, check each one of them and see where our answer will land us. Now phosphorus exhibit allotropy, yeah, where we have the white, the black phosphorus, the white phosphorus, and of course the red phosphorus. Commonly is the red phosphorus that is used to manufacture matches, remember, but the white phosphorus is stored under water because it has a low ignition temperature. Now so phosphorus is out of it, it has allotropy. Oxygen have allotropy. Of course, the allotrope of oxygen is ozone. Now sulfur exhibit allotropy, but iodine do not have allotropy. Of course, carbon do have allotropy. And what are the allotropes of carbon? We have, of course, the amorphous form and the crystalline form. The crystalline form is diamond and what? And graphite. Now so please, this kind of question, but there's one question that I usually tell my student, that be very careful. Allotropy is usually common between non-metals, but there are some metals. There is a metal in particular that exhibit allotropy. And what metal is that? That metal is what? Is tin. So tin exhibit what? Allotropy. So more videos coming up, so as I upload them, do well to always share and do well to subscribe. So there are many videos that I want to bring out in this short time for you to take your time to analyze. So do well to share with your friends, and of course subscribe to the channel so I get to get updates on these points.